G'day, it's Clive Rocksinger here. Now, I've just entered into a very interesting area here of impedance matching. Now, my problem with my circuit at home here, I'm a musician and I've got a lot of electronic gear, but I do stuff like this. But I've stepped a level up from that. Why? Because as soon as you want to put power on a circuit, this little tower is going to go up in flames. So I first developed this, which is your high current tower. And I can run directly off the mains, and I can actually get an AC waveform directly out of the mains and do stuff with it. Now, I've then gone into this prototype, which is parameter extraction for designing amplifiers, and I've built this unit here. Now what this does is it has interchangeable circuits that you can take off and mix and match and change over that are fixed circuits. So unlike this stupidity where you move the wires around and you eventually plug a wire into the wrong thing and it goes on fire, these ones are all screwed on. So you can put test units on it and test and test and test and test and test it till the cows come home. Now what you're dealing with here is you've got, I believe, I think this is only a little 4 ohm load. And you've got your output of your amplifier. Now all this is a matter is impedance matching. All you're really doing is you've got a transistor that's got the output coming off the collector, in most cases, in this particular case from a common emitter amplifier, and you've got a speaker in parallel with the load. Or the load is a speaker in parallel. So all it is an ohmage, and it's in parallel with the load. Now, what these blokes that have got these flaming big amplifiers don't understand is with an OPM, yes, you do have a simulated output coming off that, but you're coming off what's called an OPM, which is a simulated amplifier, which is the same as this, only it's got 2 million transistors in it, and it has a simulated load base so that it acts like a regular little amplifier. The trouble is that there are exceptions to the rule, and that little exception is oh, that works great and this works great. Oh gee, that's strange, why is the whole fucking house on fire? Because when you do get exceptions to the rule, all those 10 million transistors can be configured differently, and you can find yourself in peril. And I find it very interesting that all of this electronics is designed around doing tiny little things that have no power output. And that's what I do, is the contrary. So what I'm going to do is I'm going to design a circuit and amplifier, and I'm going to change the ohmage outputs. And I've got a little 3D printer, and I'm going to make up little amplifiers, and I'm going to get speakers out of cars, out of houses, and I'm going to impedance match I'm going to impedance match a 4 ohm load and an 8 ohm load. And you say, oh, now there are situations where you can't do that because of power requirements. And what people don't understand is with mathematics you can have two power supplies driving the same circuit. They call it, I think it's nodes and something like that. It's basically two-phase. So what you're actually designing is a two-phase amplifier. But what I can do is that if you have a calculation where you're working in series parallel and you can't achieve a particular configuration because you need more power, I can have a power supplied by a second fucking input power supply. Is it complicated? Yeah. It's mathematics, and that's what I do. I do the math. So now I got in contact with this guy. His name's Mikey. Radio Parts. Those are the guys that know all about this. This guy's a busker. And we talked about this area of impedance matching. I'm getting phase, I'm getting feedback. And the feedback I'm getting, I believe, is because this little amplifier that I bought from Igitech, it's not impedance matched with the speakers that I've got, and I've got these huge party speakers hooked up to this, and it's feeding back like crap. I bought a dynamic mic, which is a French one apparently, and it works good. It did suppress the feedback a bit, but I think probably the problem is I've got an incorrect set of speakers running off this. But impedance matching comes down to stuff like this, and this is the basis of it. This is where all the math is done. So I'm going to do a bunch of configurations, design an amplifier, put an input through my iPod, run some music through it, and then muck around with dB and play with different outputs, and see if I can't play and sort this theory about impedance matching and do it in theoretical and then I'm going to get in contact with this guy at Radio Parts to see if he can hook up some real amplifiers and see if we can impedance match a bunch of picking cheap shit speakers to an actual real amplifier. So this is a very interesting area. This is an area that you can't go, because I'll put this here and you try and do what I'm doing and you are not going to be able to do it. But with this stuff, I can. So this is going to be a very, very interesting issue here. I've got to make up a few more of these plastic boards. I've got the plastic down the back for this, and I'm going to make up a different the idea with this is it's in modules and you can stack that up 2 or 3 levels of these depending on how big your circuit is. And so I'm going to design this circuit and I'm going to muck around with different ohmage transistor loads, and I'm going to actually 3D print some speakers, some real little killer ones, and I put little weights in them and make them like real party speakers, real kick-ass. I've got some red that plastic stuff there, I can't remember what they call it now, filament. I've got some red filament there I just bought. I'm going to make some red speakers, and I'm going to have 4 ohm, 8 ohm, and I'm going to match them all up and make them all work. And then we're going to look at the theory of this. So this is me working in conjunction with, I really got my fingers crossed. This guy is very, very cluey, this guy Mikey. His name's Mikey Lovell, and he's at Radio Parts. And we had a discussion about this and about phase, some of the feedback. He was a busker, and he's the difference between this guy is he sells electronic stuff, but he's been out there in a field singing, and he knows the sort of issues that you come up against with this stuff. So Clive Rocksinger over and out. This is going to be very interesting indeed.